Welcome to this session. I'm talking to you from Chennai. I represent EG Innovations. Here's a quick overview of my profile. I lead the APM product development. APM stands for Application Performance Monitoring. And I have about 20 years experience in distributed systems, 7 years with EG leading the product development here on Java, cloud, and containers. I am from Chennai, and if you've ever been to Chennai, I think it's a great city, magnificent temples and so forth. So we are a long way away, but happy to connect across this medium. Okay, here's a map of our journey today. So we're going to start with why containers, because containers are important today. I'm going to go a little slow on the initial slides here, but I'll pick up the pace as we go along into the live demo and so forth. We'll go into an actual microservice application with some faults injected into it, and then we'll try to solve those issues, slowness and errors and so forth. And we'll take some key takeaways on what can we do from a performance perspective, what's the ideal solution. Now, why are we here today? Containers are everywhere today. It's going to hit you no matter where you are, whether you are in Linux or Windows, whether you're on-premise or on the cloud. Containers are going to hit you. If they have not already hit you already, they're going to hit you in the years to come. And I just took a step back and looked at, if you're a Citrix professional, obviously it's not wide open right now, but I'm given to understand by my colleagues that Citrix is already approaching the container world. It's already running it in their cloud. If you are a VMware professional, it's of special interest to you because Photon OS from VMware is fantastic, and it makes it easy for you to run cloud native and traditional side by side. And this is a game changer in my opinion. And if you are a Java.NET professional, your CTO might have already told you to migrate to containers or the cloud or the cloud, because you can also run containers either on-premise or on the cloud. So that's going to hit your world shortly. Why containers? Because the hypervisor left quite a few things short. It could not give us the agility that we require today. And you could not package the code and dependencies. Hypervisor were great because it could abstract the operating system, but we could not scale rapidly. And the most important things was the syndrome called works on my machine. You would have seen that with your developers and the testers. Whenever there is a problem, either performance or functionality, the developer will usually say it works on my machine, works on my laptop, so everything is fine, don't blame me, right? And we needed an ability to solve that problem and many other problems, of course. But we needed a predictable packaging methodology. And that's what a container is. It packages up the code and dependencies all in one big bundle. So you can quickly run it, spawn it across machines and get going on it. Now, I just want to take a step back and look at the container in relation to the others. If you take a physical machine, that's a heavyweight because you can't scale physical machines quickly. You'll have to add new machines, provision, get signatures and so forth. And even then, the physical machines are not good use of your resources. You'll be wasting resources. So in came the hypervisor, the virtual machine, which is sort of medium weight. You could still give a knockout punch on the resources. You could squeeze the max out of it, but it lacked the scalability, the ability to package quickly and run for example, an old Linux on a brand new Windows host, or vice versa. So in came containers, probably in the last decade or so. It took off because it's lightweight, it's predictable, it's easy to package, it's easy to distribute. So containers are absolutely the future, no doubt about it. It's going to hit your world. But containers are not enough by themselves. So if the ideal analogy that I use are containers is a bunch of ragtag musicians sitting in a park. One is playing a guitar, one is playing a drums, some sort of a makeshift thing. All these are Java apps, your .NET apps, and your Python, and your everything else, all playing and running alongside each other, but competing for the same resources on the same machine. So you're going to get some kind of a music, but that music is not going to be a great music, right? You're not going to pay for it, I guess you, right? So you're going to get some sort of a random kind of a music. What you need to create music is an orchestrator, is an orchestra. Somebody who says, when should you start playing? When should you stop playing? When should you play faster? When should you play slower? When should you play quieter? Or when should you play louder, right? Somebody is there telling each of these musicians the directions. And that's Kubernetes. Kubernetes is the orchestrator for the many musicians who are the containers. I hope this analogy makes sense so far. So the Kubernetes is telling each of the containers, hey, you .NET, you are experiencing a big traffic coming in. I'll spin up more of you across these machines. And it's going to spin down also machines that are quieter. For example, if it's a home page of some blog or something like that, which is also running, it's going to spin it down and it's going to stop a few containers up and down as needed, as per the demand. So that's Kubernetes. It's telling you the entire orchestration. Now, quickly, I'll zip through these. So we know the takeaway so far is containers are important. They are everywhere, but containers are not enough on their own. We need an orchestrator. Kubernetes is the de facto orchestrator today. It's taken the world by storm. It does a lot of things that for our benefit. We don't need to be micromanaging these containers anymore, right? It schedules it, it scales it, it checks the health. If a container is sick, for example, it's experiencing out of memory, it's going to kill it quickly and it's going to do a health check and spin it up somewhere else. If that host machine is stressed out, it's going to move it to a new machine. It's going to recover the container. I'll give you a live demo of that in a few minutes. So there's a lot going on. It's doing the network management. It's doing balancing. It's doing discovery of new containers. It's doing resource allocation. It's balancing everything. In short, it's doing absolutely the heavy lifting for you. But there is a sacrifice we have to do, right? There's something we have to pay for it, for all this benefit. And that problem is complexity. So why is it complex? Containers can come and go across machines. 1 minute they could be there on machine A, and the next minute they could be migrated to a machine B. Pretty much like the VMware vMotion, but on a whole different scale, because all these micro containers are moving here and there. Left to Kubernetes' best judgment. Not only that, there's an absolute explosion of metrics as compared to host only. For example, on a host, there might be 100 metrics, for example. The typical thumb rule is if there are 100 metrics in a host, you'll be dealing with 500 metrics, same host with a bunch of containers running on that host. So the explosion of 5x, sometimes even 10x, depending on whether you're running on-premise or the cloud, because the cloud brings in a whole new complexity. The third complexity is the fact that a single app is running across multiple containers, which in turn are running across different machines. So earlier you were just looking at the task manager or the top command on a single machine. And then you said, I'll look at it on one hypervisor. Now, how many hypervisors are there? There are so many thousands of these small micro containers. How many will we keep an eye on? Right? That's the complexity. It's just complexity at a different scale. I'm going to quickly go into the demo because I spent about 10 minutes giving the context. What I have created for you today is a real life clone of an Amazon kind of a application. which I'll give it to you. You can access it yourself, and I'll also paste it in the chat window. So you are the IT manager for a 24/7 cross-geography application, which is common today. You get paged at 2 a.m. in the morning. Customers are flooding your call center, complaining that they're not able to place orders. This is the typical scenario. And just to give you the setup, the application that's under question is a completely containerized application, as you can see here. These are the various technologies. We have put together a set of modern technologies that you are going to encounter or you will already encounter out there, namely Docker, which is the container. Kubernetes is the orchestrator, as I said. It's sitting in the middle here, orchestrating all these containers. And this application itself is what we call as a microservices application. In other words, it's not a one gigantic service, it's a microservice. So the name suggests that it's a small encapsulated API that's doing one thing and one thing only, but doing it very well. And that's the new architecture companies are going forward for. So the whole idea of a Docker Kubernetes is an enabler for a microservice. And just for additional complexity and just for ease of use as well, we put it on Amazon AWS, and it's a Java application. So it's running Java Spring Boot, which is an API. It's a framework for Java. It's running the Java virtual machine, the JVM, and the application server is Tomcat. Could very well be WebLogic or JBoss and so forth, which I'm sure you would have encountered on the field. So right now, everything is Dockerized, as they say. Kubernetes is managing it. And the payments tier, just want to call it to your attention, also has a dependency on a real-world third-party Visa, MasterCard payment gateway. What's your next move? So I said you are the IT manager. Are you going to be calling out for a war room at 2 a.m. in the morning? And my next question is, if you're going to call for a war room, who are you going to call? Are you going to call a few people or everybody? And the reason I'm asking this question is because if you take performance problems, they could span anywhere in the whole landscape. It could be an app problem like this, a code issue or a SQL issue or a third-party issue. A vendor has to fix it. If it's a SQL, either the developer or the DBA has to fix it. If it is a code, the developer has to fix it. If it's the infra, on the other hand, it's the JVM administrator or the Tomcat administrator. You could have a separate team for a specialized skill set on Docker and Kubernetes. Are you going to call them? And you could have the traditional sysadmins on the host OS. Are you going to call them as well? You might also suspect networking is the issue or storage is the issue. So we have a wide variety of root causes out there. How are we going to tackle this issue? So in order to demonstrate this, I'm going to jump in. It's almost 15 minutes since I started. So I think it's the right time for us to get into a demo. I'm going to paste this URL, but it's pretty easy to access yourself. So if you just hit bit.ly, this bit.ly URL, the URL is e2evc_demo. And that's going to take you, I'm going to open it myself and I'll show you the actual e-commerce. I'd like you to register with a fictitious email ID. Don't give your official email ID or anything like that. Just a fictitious email ID, and then we'll actually discover you and we'll go from there. We'll see how to troubleshoot this further. All right, so with that, I'm going to switch to the browser. Just give me a second. So as I said, the link is bit.ly. And it's all caps. So it'll take you to this web store here. And you can actually sign up using a fictitious email. I'm just going to give my name, but you're free to use any other fictitious name and email ID. So I'm signing in here, and now it's going to take me to the home page where I can see typical Amazon kind of a website. There are books and there's electronics and so forth. So I'm going to go ahead and add to cart, and I'm going to view the cart as usual. And I'm going to check out as we usually do. And now I have a choice of either using a Visa or a MasterCard. Now we have actually intentionally created a slowness in the MasterCard payment gateway here, just to show you a real, this happens with us usually. We click something, it just times out. So I'm going to click this. It's submitting my payment details to the gateway. But I'm starting to get a little nervous now because it's not coming back in a timely fashion. Okay, so I gave my credit card details, and I'm worried now because it's an internal server error. So I submit it all over again, and no response. Nothing is working for me. I'm getting frustrated here. It's Black Friday. I'm getting frustrated, right? So just to show you, the Visa works fine. We expected success. We expected this from MasterCard as well, but somehow me as a MasterCard, I don't have a Visa card. I couldn't complete my order. I'm irritated. I'm angry. I'm a high value customer. I'm calling the call center. So how do we deal with this? Now, we know now that there is a problem in the MasterCard, but how do we actually pinpoint this? So one of the ways to do that might be just logging, for example. So if you have good logging, hopefully you're using a log file monitor and you're seeing something like received failure from MasterCard or something like that. But the problem is, this issue could happen anywhere in the whole chain. It could even be in your own code. It could be from MasterCard. It could be a host of other issues. It could even be the fact that the proxy server is down or something like that on the way out to MasterCard. So how do you fix it? The other problem is, I just told you there are hundreds of containers. The whole point is that we have gone into a microservice because we want to distribute it across hundreds of containers, not just one monolithic. And therefore, I have hundreds of log files. So my job, if I'm using simple logging, is to now aggregate all of this, send it to something like Splunk, for example, and then look for anomalies, which is one way, but hopefully we have other ways. So I'm going to use EG Innovations, which is the product we develop at EG. And I'm going to straight away take you to the topology diagram, which right away tells me, I'm just going to, just for the benefit of how I arrived here, I am at the real users monitoring dashboard, first of all, which tells me that real users are coming in and there is a high server time here. So I click on it and it takes me to the topology where there is a problem on the payments. Now, this is sort of an automatic topology that is drawn because we have automatically discovered all the layers. And there are 6 Docker containers here, as this number indicates. And the payments automatically is telling me that the response time is high for MasterCard. And the reason I know it's MasterCard is, one is I can look at the alerts, which I'll show you in a moment, but I could also look at the link here. Let me just expand this. Anyway, I'm going to drill down and see where it takes me. So I'm going to drill down here. me pick something else. I'm just going to go to the reporter, and so I'm going to go. To a custom report called a slice and dice analytics, and I'm going to pick the payments microservice and run this report. And I know I can see slowness in this dashboard. So I'm going to pick a slow service here, a slow transaction. And now I can see that it's MasterCard, right? There were other healthy transactions here. So Visa was fine. As you can see, this pictorial representation. The Visa payment gateway was absolutely fine. Everything is green. But when I look at this one slow here, it took 20 seconds to come back. And there are also potentially errors, as you can see here. And if I'm a Java developer, I don't want to go through log files. I don't want to go through my source code. I immediately want to drill down into what's going wrong. So ideally, I want to jump in straight and say, okay, MasterCard sent me a error 500, HTTP 500. HTTP 500 is something like something went wrong, grievously wrong. So I can now pick up the phone and call MasterCard, raise an urgent ticket, and have them fix that, fix the downstream service. Now, there are other good things about ensuring that we have a trace, drag and follow kind of a solution. It could be EG or it could be any other APM. But the idea is, for example, we want to start with the user experience view. So for example, I could go to my real user monitoring and pick the I'll just pick a slice and dice here. And I'm going to pick either the slow or the error. Okay, I see a few usernames with E2E. So this was something I wanted to show you. You're seeing my email ID over here. That's Arun. And there were a few others who have logged in with E2E. So this is an example where I know that a person with a certain email ID or a login name is frustrated and is experiencing slowness on the server. And that's because of MasterCard. I hope this sort of a two-click makes sense, because I started with the user experience. I know that if, for example, this is my VP who is frustrated, I can look him up or look her up on the console, look at their experience. It's not the browser. The browser is absolutely fine here. It's the server. And when I click on it, I immediately know it's MasterCard. So I can go back with an intelligent reply saying, it's not us, it's somebody else. And from there, I can drill down into the actual gateway. So it's MasterCard. If there are errors, that will show. If there are sequels, that will show. So I hope this flow sort of makes sense. I just wanted to go back to the topology. And one of the important things, something that's important for us as IT support is, who is it? Who should I pick up the phone and call? Should I call the app team or the infra team? So something that's useful is a topology diagram like this, because it's telling us now each of these boxes are the tiers, the actual application that's running, but it could be the infra as well. So right now the infra is absolutely fine, but I'm going to go to the console and actually create an intentional crash right now. So I just want to show you the fact that I am running on AWS. So I'm running a Kubernetes command here called kubectl, which is showing you the fact that I've got 3 nodes on the AWS West region. And I can also get all the pods. So pods is a think of pods as something that encapsulate a Docker container. A pod is an encapsulation, a Kubernetes encapsulation of a Docker container. So right now I have front end, I have customer, I have MasterCard payment gateway, payments, products, and so forth. Everything is fine, everything is running, and that's why you see a green tick here, right? But I'm going to go ahead now and I'm going to create an intentional crash using this command over here. So what I'm going to do is I'm going to create this command over here. What this is doing is it's going to create a crash loop, which means it's going to create a situation where the container is in a sort of a crash, tries to come back again and tries to crash. Example, you may not have sized the container correctly, you as the infrastructure person, for example, by mistake or something like that. If there are not enough resources for that container to spin up, it's going to keep trying and keep crashing. So when I run this again, the same command, it's going to get the pod information. And you see here that the pods are not in a running state. They are getting killed. They are in a crash loop back off. A crash loop back off is something like, it starts crashing and then it backs off and tries again to get up. But due to the inadequate resources, keeps getting crashed again and again. It's like a poisonous chain. So when this happens, we need the ability to know about it. So I'm just going to refresh the topology, wait for a few minutes just for this to reflect. Let's see here. Let me, sorry. Let's see if the gateway pods, some of them are running, some of them are crashed. Let me try to hit them again. And hopefully, if everything works well, I should see some alarms over here. Anyway, so what I wanted to show you, I don't know why the latency is there, but ideally, let me see if the alert should show up. Try coming back here. Okay, I think there's something going on here. So if you see here, when I click on this icon, now I'm seeing something similar to what happened. So there are some containers getting killed. There's container termination happening and so forth. So we need to understand what that is. So what's going on? Which container is it? Which tier is it? Which tier is facing the problem? So remember, I went here and created an intentional fault in the Visa payment gateway. And that's what is showing here. The Visa and the payment gateways, the pods, which are an abstraction of the container, that's stopping and it's getting killed, which is not a good thing because all my payments are going to get slow now. So just to recap, I showed you an example. I showed you two examples just now. I showed you an app example where the third party was to blame. And now I just showed you an infra example where because of an improper configuration, the pods are crashing. So we need abstractions like this in our work for us to succeed, because we need to know who to call. Should I call the infra people over here, or should I call the application people over here, which is code, SQL, and third party? So going back to my slide again, if you remember, the left hand side is all the application developers and the DBAs and so forth. I'm including the DBAs. Some people might say a DBA is an infra person. That doesn't matter. But we need the clear demarcation between the app and the infra. We can't mix them because each one has their own kind of tools. Each one has their own siloed tools. And they say that I'm fine, I'm not to blame. If you're the IT manager, you're going to go crazy thinking what's the real root cause here. So another thing that I wanted to show you was the ability to slice and dice these things. So going back to the reporter, we need the ability to slice and dice across each of these. So for example, when I run this report, okay, I'm seeing a few more usernames here. So we are seeing, okay, people from Belgium and Czech, that's nice. So we actually automatically capture the country. We even capture the username. So let's check, it's Gundaris, for example, just pick him or her. I don't know which person it is, but let's say they are the VP or they are the important stakeholder in your organization. And they come to you saying, I tried and I'm having a bad experience. We cannot go back to the logs and hunt for this person in hundreds of log files. We can't. I mean, it's possible, but it's going to take us a long time and it's very painful. So ideally, we need the ability to look up a person by their name, look at their journey. So here there is a journey as they went across different times, and look at the slow experience and say, okay, I've located it. I know why it's slow. It's not slow because of the network or the browser. It's because of the server. I click on it and instantly know it's MasterCard. That's the cause of your poor experience. And ideally, we do all the hard work to keep our servers running. Some other third party causes pain for us, and we get the impact of that. We don't want that. So we want the ability to quickly triage and just pinpoint the root cause. Okay, so I'm just going to go into something else here. So we have looked at the fact that we start with the end user experience. We need the ability for microservices applications to trace all the way from the backend from the front end into the backend, and trace all the way to the remote machine, or it could be a remote service, trace all the way back, pinpoint errors, pinpoint slowness. That's good. What happens when, let's say, the database comes into play? 90% of, let's be pragmatic, most applications are DB bound, and they are stuck on the database. So before I go into that, I don't know if I'll have time for that comprehensive demo, but I just wanted to quickly show you something else before we move on. So we also need the ability to visualize the health on a dashboard, possibly on an LCD or an LED screen somewhere, so that people understand the health of it. And something like this, this was built automatically. I can just show you. I'll try to recreate it, but I just want to take a few minutes to explain this dashboard, which actually got created automatically, but I'll try to do that. So ideally, I don't want to start with the low-level infrastructure bits. And that's my key message throughout this presentation. We want to start with the high-level overview of the user experience, which I showed you in the browser. But if I am the owner of, for example, the payment microservice, I don't really care about the browser. That's for another team. That's probably for the front-end team. I care about the payments microservice. And for me, I need to keep an eye on the slow percentage and the stalled percentage. Stalled is something like people are absolutely stalled. They are not able to move forward. and the errors as well. And if I am the CTO, I need to keep an eye on all the microservices like this and know that the payments are getting stressed out right now, obviously. Another thing I wanted to show you was, we talked about Kubernetes, we talked about infrastructure, we talked about the fact that containers are underpinning the microservice. It's not enough to look at containers in isolation. We need to connect the dots between the various microservices and the containers. So for example, this dashboard is telling me that 7 failed pods, which is basically container, in the MasterCard payment gateway. So I can now take action on the specific pods on the MasterCard. I'm going to allow some time for questions if possible. So I'm going to just quickly go into another dashboard here. This is an example of an infrastructure kind of a dashboard. The earlier dashboard I showed you was like a service dashboard where I am the service owner, I'm the CTO or possibly the lead for a microservice. This is, I'm the head of infrastructure for my Kubernetes cluster. And I need to keep an eye on all the health of my entire cluster. So this is the infrastructure view. But the point is, if I start with this dashboard, it's not ideal. We want to start with the service experience first. Otherwise, we'll be looking at all the pods, the thousands of containers that are running around the cluster. Yes, we need to keep an eye on it, but the starting point is the service, the microservice. And now I can, yes, if there is I showed you the fact that I intentionally created a failed pod crash. So that was on the payment gateway. And that's what this is showing, the pods in the failed state. This is not good. We need to correct it. So that's what this is. The impact of this was felt on the user experience. And it's important to distinguish between the infra people and the app people. They are two different stakeholders. Should I pause for questions now, or should I go along, Alex? I think I'm almost done with, I can keep going, but if you want me to pause for questions.
No questions yet.
Okay.
But you can keep going. You can keep, you're still good on time.
Okay, great, cool. Something else we can go into is the fact that we have talked about containers, we have talked about Kubernetes, we talked about the ability to filter by user, filter by IP address, filter by the URL, for example, filter by the country. You could be coming in from a mobile, you could be coming from a device. Now, I could also be having issues with the JVM, which is the Java virtual machine. In this case, it's Java, but it could also be .NET, or it could be PHP, and so forth. And we need the ability to, once we know that it is the infra issue, the topology that I showed you earlier, that's going to tell us that it was the JVM, and then I could go into a sort of a memory analysis. If, for example, the memory is a problem on a certain Tomcat server, this memory, if it's trending up, right now everything is fine, but it could be trending up, and it could eventually go out of memory. So that is a problem. That is a problem. It'll ultimately affect all the servers. It'll go down. It'll affect your user experience. So the point of this is, again, going back to my slides over here, the report I showed you is over here. We covered code, SQL, third party. We also covered the fact that it could be Docker, it could be a failed Docker pod. It could also be the host operating system, for which we have other reports. But if you are the CTO, if you are the head of the IT infrastructure, we need to start with the user experience, go into the infra level as required, or it could be the code as required. So something else I wanted to show you, since there is time, I am also, I can create an issue on the MySQL. So right now I am logged in into the MySQL console on Amazon. So I can go ahead and create a slowness over here. So I've got a command for, I can lock a few tables. It happens typically if we haven't coded it the right way. For example, let me just make sure my OT session is, I'm going to close this. And I'm going to log in into this over here. I'll just make this a little just change the font to make it a little more readable. Okay, so I can now just log into this server. I'm now inside the Amazon console. I'm going to now get into the Docker container that's running MySQL. I'm on the MySQL command prompt. I can actually now create, I can first log in into this database, and I can create an intentional lock over here. So if this happens, going back to my web store, it's spinning, right? I'm not able to go to the next page because I just showed you I've intentionally locked the table. So it's not able to insert into the cart table here. And this could happen because, you know, there could be a backup job that's running. That's probably either there's a bug in the code, or it shouldn't have run at that time. It got created, it got spun out of error. It's locking up the table because of poor concurrency and so forth. So that could happen. And when that happens now, going back to my whole point here, the log files are going to be of less of a use, or rather, you know, it's not going to directly tell you that the DB is a problem. Because what happens is the code is now waiting for that statement to commit, and it's not able to commit because there is a lock on the table. So now, ideally, the DBA should kill that offending process and release the lock. But how do you even know that the DBA should commit, right? And ideally, again, we need to connect the dots. So going back to the topology where I came from, the topology should ideally tell me that there is a problem in the server. So as you can see here now, yes, there are the failed pods issue that was earlier. I can release it. I can make that go away. But I want you to draw your attention over here, which is the fact that the DB is slow. So there are many lock waits, many long running MySQL, which was because of the bad job that I told you possibly. And the fact that my web store is waiting for a table level lock to get released. And it's also telling me the SQL. So now I can pick up the phone and call the DBA, right? The tools that we use have to help us isolate the problem quickly and help us call the right person to fix it. So in this case, it's the DBA. I'll quickly summarize, since we're pretty close to time. Performance problems are of different types. Could be app problems and infra problems. You need to know who to call. Don't call everybody, because you can't wake them up at 2 a.m. Everybody, they could also be in different time zones and so forth. And so here's a quick summary, right? Containers and Kubernetes, absolutely powerful, no doubt about it. It's going to hit your world, but they are a complex beast because of the many moving parts, because of the fact that requests go across containers, across machines. We need the ability to trace it all the way. And log monitoring doesn't help. Simple log files will not help. Ability to trace that request, ability to isolate it. We need the transaction tracing, which possibly an APM tool can help with. High to the low. Yes, we have traced it, but I don't want to start with the infra details. I want to start at the high level service view. I want to start at which microservice is the problem. Is the payments the issue, or the customer facing front end is the issue? What's the issue? Then we drill down to the code, SQL, or the third party, or the infra people, in which case it could be network storage, Kubernetes, Docker, etc. Call the right team. Don't disturb everybody. Call the right team. Thirdly, I talked about Kubernetes and Docker. The moment you put Kubernetes and Docker in AWS, the whole game changes. Because not only do you have the complexity of a microservice app and a Docker and the orchestrator that's Kubernetes and the Java app, but you also have something like AWS coming in. And AWS, it could be again be EC2, for example. An EC2 could die, or EC2 could run out of CPU or out of disk. And now you're swimming in metrics. How do you make sense out of it? How do you make meaning out of it? We need the ability to correlate stuff, because there are just too many of them. So with that, I am finishing up my presentation. I can take questions. My final point to you is choose wisely, and thank you.